Fairview Christian School, and we decided we wanted to do this STEM project.
To do something with global warming.
You know what? Global warming! Global warming!
Because global warming is really bad. It melts icebergs, it floods islands, it even makes animals extinct. At first we didn't know how to relate it to math, but then we had an idea. Brain blast.
Our challenge idea was to calculate the cheapest and most practical way for Washington to reach 1930 CO2e emissions. CO2e meaning CO2 and all other greenhouse gases like methane and nitrous oxide that cause global warming.
And thought of all the different things that produce carbon dioxide.
There are cars, trucks, tractor-trailers, motorcycles. There are coal-burning power plants, natural gas-burning power plants, and fossil fuel-burning appliances. The list goes on.
Then after we thought of these things, we thought of things we could replace them with that didn't produce greenhouse gases.
We thought of some friendly electricity-making techniques like windmills, solar panels, and dams, and nuclear power plants.
Then there are electric cars, trucks, motorcycles, and even semi-trucks. But all of these solutions cost money.
The thing we realized over and over was we had tons of variables and we couldn't just calculate hundreds of thousands of different solutions. So we decided the most organized and least time-consuming way to calculate everything would be to put it all in an Excel spreadsheet.
First thing we put in the spreadsheet was what 1930 emissions were, which we had to use math for because there was no data on the internet about 1930 emissions. We set up a proportion in Excel, 2010 emissions over unknown emissions and 2010 population over 1930 population. Then we solved for X.
We started researching and finding how expensive and how much CO2e different things produce. We based much of our research off of EIA.gov, WSDE, the Washington State Department of Ecology, and DOLA.gov, or the Washington Department of Licensing. From there we found lots of current emissions and other essential info.
Now we have 11 tabs total in our spreadsheet, which we linked together so that we only had to find certain data and the rest was automatically calculated from the data.
Our first tab of the 11 is 2010 emissions. This data we got from WSDE. Our second tab is the population of Washington in different years. Then, of course, the 1930 emissions tab with the proportion in it. Next is the constant tab, which we used to link things to. So whenever we had to add time to the calculation, we had it in constants.
Is the vehicles tab, which includes vehicles total production and different types of vehicles contribution to the total production, their gas mileage, and many other important things that contribute to the calculation.
The next tab is RCI, or Residential, Commercial, Industrial, meaning all of the fireplaces, natural gas boilers, and the coal furnaces used for heating.
The next tab is industrial processes. It includes stats for things like cement manufacturing, aluminum production, soda ash, and semiconductor manufacturing.
Next is the electricity production tab, which includes stats for the polluting data including coal, natural gas, and petroleum power plants. It also includes how expensive newly constructed non-CO2 producing forms of electricity are and the quantities of electricity they produce. The next two tabs are waste management and agriculture. Both contain emissions mostly attributed to human and animal waste. The idea here is that you can try and capture and burn methane produced, because methane in the atmosphere is 27 more times potent in global warming than CO2.
Then there is the total calculation tab, which is where the program runs. The sheet is laid out with 32 variables. Each has a minimum and maximum.
For each variable, the program randomly generates the number between the minimum and maximum, then inserts the value within the assigned value cell. The program then allows the spreadsheet to recalculate. After this, it looks at the total cost and total emissions calculation cells. If the total emissions are less than 1930 emissions, it next looks at the total energy shortfall and the total energy produced. If the new energy produced exceeds the shortfall, then it inserts the 32 variables assigned values ordered by lowest cost.
Running the program for over 36 hours and 10 million iterations, we arrived at a host of options. These are the final emissions that the program calculated. Some solutions include building new nuclear power plants or hydro plants. Almost every solution requires building lots of wind power generation and converting large volumes of vehicles to electricity. In addition to solving this 32 variable problem, one benefit of the random variable approach is it helps formulate a wide variety of options. Imagining that out-of-the-box solutions, like what our spreadsheet shows, might be what this difficult and real-world problem needs. The solution that we picked for Washington to reach 1930 CO2e emissions cost over $2.7 trillion.
Here's a list of our credits, and a special thanks to Powtoon, who let us use their pictures and cartoons.